Okay, welcome back, everyone. The word I was looking for earlier was accelerated computing. I mentioned that one, but it didn't feel right for some reason. I don't know, but it's called accelerated computing. So moving from general purpose computing to accelerated computing is basically looking at special purpose computing. Like doing for particular tasks. All right. So one of the other things that talked about in AI is there's different stages. So you will hear these or see these in different places. We talk about uh, artificial narrow intelligence or narrow or weak AI. So what we meant by narrow AI or weak AI is that so they are basically looking at doing specific tasks like driving a car or controlling a automated greenhouse or surgery and robotics. So basically they are looking at doing specific task, particular task, rather than doing things in general, which is supposed to be the next stage, where we look at artificial general engineering or AGI or strong AI, where the AI will be capable of doing different multiple tasks rather than a specific task. So there are wild guesses about how and when this is going to happen. I know if you read about ANI and AGI, people will say it will be to 2035, 2040, 2050. We have no idea how it's going to be. Maybe it's just it's already happening, right? But there are predictions as to what, how, and when it's going to be. Nobody really knows. Nobody has a crystal ball to say when it's going to happen. But it's on the cards and it's going to happen. And then you have what is called artificial superintelligence, where this says that the intelligence would be superior to humans in every possible way. And then you say it can be a risk to the entire humanity and so on. And all these things are just conjecture. We don't know what's going to happen, right? How we coexist with AI, what's going to happen, how we're going to adapt. These are all happening at the moment. What we do and how we'll decide on how all these things goes forward, right? So, but this just to see that it's coming in, and how things are going to turn out, we'll have to wait and see. Okay. So the current status of AI, very quickly once again, right? As I mentioned, we have machine learning. I'll just quickly touch upon machine learning because everybody's talking about machine learning, and it's kind of turned out like depicted to be very complex. Of course, it is very complex, but it's very simple as well. Natural language processing, as I mentioned, both sides, speech and text. Computer vision, robotics, and all that. So you have these different areas. Let's just quickly look at machine learning, because one of the reasons is that, as I said, machine learning is talked about and it's used in every possible field at the moment, in agriculture, in medicine, in finance, everywhere. Just to understand the complexity and bring it down to something that can be understood by anybody, right? Now, machine learning, when you say machine learning, what are we really talking about? Now, to understand machine learning, we need to understand what learning is about. And if you understand about learning, it's easy to understand these different aspects of machine learning. For example, we have like three main areas of machine learning. We start with supervised learning. So supervised learning, I try to take examples from how we learn anything. Like, so just to say how we learn anything, it's easier to take an example of how a baby would learn something, right? So when you say supervised learning, what it means by supervised learning is that you will show them, tell them what to learn. Like you will show them A and say this is A. You will show them B and they say this is B. You will say this is table, this is chair, right? This is blue, that's red, right? And if you say it to once to a kid, will they learn it? Obviously not. You have to keep them showing A so many times. If you show them many, many times, this is A for apple, A for B for ball, and keep doing that again and again and again, they will learn. So this we call labeling, right? You show an A and we say this is A, right? That could have been anything. If this letter could have been Z, who knows? You could have called it anything you want, but it's A, right? So A sound, this is A, and in my language, A would look entirely different, right? So you show them and label it, and then you can learn it if you see it enough times, right? Just once and all that, no. So this is the same thing that we do with machines. You label something and you keep showing that many, many times, they can ultimately learn. Right? So that is called supervised learning. And unsupervised learning is everything else, basically. Like you see things, you have not, you didn't learn everything that you know today by somebody telling you this is what it is. You see things, you see let's say a cat and a dog, and then you see other animals, and you don't even know what that animal is, but you can categorize them. You don't know what that animal is. Now, if I go to agriculture field, I don't know what this tree is, what that tree is, and so on. But I know that's a tree, and I can understand, I can recognize between different type of trees. I might not know what that tree is, right? So that's called unsupervised learning. You don't know what it is, but you can look at the features and then cluster them separately. That is called unsupervised learning, right? And then you have reinforcement learning. Again, if you take a kid, you go and touch the fire, they learn not to touch fire ever again, right? It's called reinforcement learning. You get a feedback, and you never do that again, or you get a positive reinforcement, and you'll do it again. Okay, so this is basic. This is the basic principles of machine learning. This is all that is there. Of course, if you look at the underlying things, okay, so this is some examples. I'll just quickly go over that. Right. So basically, what happens is that supervised learning is kind of task driven. You train them with particular labels, and then you try to predict the next value. Unsupervised learning is more data driven. So it's like you give them a lot of data and you try to identify clusters within them, and you see this happening more and more, because when you have 1.7 trillion amount of data, it's not possible to label everything, right? And then you'll learn from the mistakes. Now, once again, it's not just about labeling, and maybe I'm making it so simple and say it's just labeling and you can learn. No, it's so not so. If it's a classic example we used to show in the class, earlier about this, the labeling is like one example is that this when they were using this machine learning to identify between enemy tanks, the presence of an enemy tank and the absence of enemy tank. So they got pictures of enemy tanks and no tank. So they labeled it, they trained it, and then they trained it and they tested with the testing data. It worked brilliantly well. And then they went and put them onto the field, and they failed spectacularly. And they went back and looked at why this failed. Now then when they analyzed this data, what they figured out is that the pictures that were taken of tanks were taken on a bright sunny day, and the pictures of no tank was taken on a cloudy day. And you're just saying this picture is a tank. You're not identifying this is the tank. You're just giving this picture and calling it a tank. And then what the machine had learned is the sunny versus cloudy to be the tank and no tank. So in this field, when you go up and put it, it definitely fails, right? So, it might sound like, it's a simple thing, but data labeling, identifying data is actually the most difficult part, because if you don't correctly label them and then put them, so that's where the data curation comes from, then what it will learn will be very different from what you think it should learn and it will learn, right? So it's not as it sounds, right? But of course, this is like, I mean, this is simple, but it takes a lot of effort. You need to learn from the mistakes and see what gives and all that. Okay, I'll just skip that. So, and as I said earlier, like, you don't, not true for you to learn, but I mean, when I'm saying this supervised learning, it's very simple. Of course, there are so many different models, algorithms, and all, not to worry about this, but just to say, I know there are a lot of different things going on underneath. Now, this, we had to learn these things previously, but now, what has happened in the last decade or so is that this has become actually more and more accessible to many people without going into the deep into AI with the emergence of deep learning and deep learning tools. So earlier, if you wanted to do machine learning projects, you had to know all these specific steps, and you had to go like, these features, extracting the features, training algorithms, underlying algorithms, and all that. You had to learn all these things. But now there are enough tools where all these things are automated. You just have to look at the data and the output. Right? There are enough courses, enough tools online available that you can actually go and look at how to just give your data and get the output and see whether it's doing what you need. Once again, when I say it's easy, it's the same thing as, I mean, what I say is like, so normally this is like, learning to drive a car, right? I mean, you don't need to be you don't need to be a mechanical engineer or anybody to drive a car, right? You just need to learn what input to give, right? Put the fuel, start the engine, give the accelerator, press the accelerator, and the vehicle will move. And then you learn how to maneuver it, right? So does it mean that the first day you just sit and you can drive like Lewis Hamilton? Okay, you may never drive like Lewis Hamilton, of course, right? I mean, why Lewis Hamilton they are so good is they actually understand every single thing that happens. They know when they touch the accelerator or anything they do, they understand everything what is happening inside the vehicle. So they know how to predict everything. They are so good because of that. So if you really know what's going on under the hood, you can be really great. Doesn't mean that you need to be you need to understand how the engine, whether it's a V8 engine, V6 engine, or whatever engine. You need to know just to drive well. It also doesn't mean that you will drive well on the first day. You need to train. Right? You need to understand how to give the input. You need to understand how to steer. So it takes training. So it's just not that since because there are tools, you can just get the data and put that and get the output. No, you have to try. You have to keep trying the same way that you will learn how to drive a car. Right? So if you learn how and what type of data to give, how to curate this, and you can become better day by day, it will take time. Right? You're not going to be like, be Lewis Hamilton on day one or maybe ever, but you can come to at least a certain stage. So there are enough tools, enough things that are there now that you can actually try your hands on deep learning and so on. There are a lot of other areas also that people discuss when they discuss about AI. People say AI, machine learning, deep learning, and also data science, data analytics, and all that. Interchangeably, they are similar but overlapping areas. For example, if you take data analytics has been there for centuries, right? You just have data, you can analyze data. It has nothing to do with computers. Data analytics has been there for centuries. But when you combine that with computers and machine learning, you come up with data science, where you can actually look at data and come up with some insights from the data that you can use for different purposes, right? So what's the importance of this one is like when you look at data and when you do analysis, it's not just about the mathematics. It's actually about the domain. So this is why, this is in the workshop, you will see that, what we're trying to do is not to come and tell you how to do your job, because we don't know. Right? We can show you how to do the different things from areas of the computers and statistics and all that, right? But domain, the subject domain is your own. right? So I can't come and tell how to do agriculture. Never get agriculture data. I don't know anything about I mean, a little bit. But if you want to do something meaningful in agriculture, you need to get the data and analyze the data and use agriculture experts to actually to analyze and make meaning out of it. There's the same thing with bioinformatics. That is the biggest problem we have it in bioinformatics. Biologists don't know computer or programming and engineering. Computer engineers don't know biology, and there's always a huge gap between these two areas, right? So there are, but now we see that people are learning both ways, especially in our department in back in Peradeniya. Almost every final year project is some sort of AI ML projects, but all are in other areas like medicine, dental, allied health, agriculture, finance, like every single area, in that you can think of, right? But we need to bring in this domain knowledge, right? So what can ML do and cannot do? Very quickly, once again, if you have a simple concept, if you have a lot of data, then you can use machine learning. For example, like, if you have a lot of data about cars, self-driving cars, you can identify other vehicles that are going in. But for example, as I keep joking, back in Sri Lanka, we'll probably never have automated cars in Sri Lanka because of the traffic, the way people drive and all that. And also, if you like, this is like the policemen in Sri Lanka. So this is like, they're doing hand signals. So this is like a hand signal like this. In three separate things. The first one, they are asking the vehicle to stop. The other one is they are asking the vehicles to go to the side and stop. The third one, they are doing the same thing and they are asking the vehicle to turn. Right? So if you use this to train, you will not know what you don't know where the vehicle will go, right? So of course, that kind of data is not going to be helpful. So it will not work. And also, like, if you take medicine, you can get just few images like this in textbooks to train the students by showing few images to show what pneumonia look like. But this is not enough for you to train a computer. Right, so you will need about 10,000 label images to train a computer to identify pneumonia patients, but only few textbooks, few pictures in a book will be enough to train humans, right? Right. Okay. I'll skip these things. Sorry. So the different types of projects that you can do with, like, data science and machine learning. Once again, things like, so this is machine learning. You can actually do like entire series of things, like from starting from the end, like beginning. You can get them, screen them, do the review, and do that. Can have an entirely automated thing with machine learning. So that it basically, for example, if you're a HR manager, you just keep doing this. You can get the machine to learn what you are doing and try to do that to a certain level, right? But when it comes to data science, it's like, for example, in each stage, right? Let's say you get what do you call CVs, right? You can just use it to just screen it, right? And then filter it and identify, and it's based on the previous things and what you need and so on. So you can get the data out of it for the next stage, and then the human intervention will come and you will go to the next stage. So you can build this one stage by stage by looking at the data and get the insights from it. No, it's not as simple as that, as I keep saying, but this is basically idea. For example, let's say in agriculture, right? You can just use the data, do a crop analytic, right? Identify how things are growing and what it's just to get information about how well things are going. Whereas in machine learning, you can get something like a precision weed killer. The machine to go with, identify where the weeds are and, have a precision killer or automated greenhouse. So, similar things, but doing different activities. So there are many possibilities like this. Once again, what we need is for the domain experts and AI experts to come together so that we can actually identify where we are going. So one of the other things that I just want to mention, this is the question that many people ask with AI: are we going to lose our jobs? right? Is AI going to take over the jobs and so on? So we don't know, right? But this is from the World Economic Forum Future Job Report that was published in January this year, 2025 Future Job Report. Now, a few things like 5 key labor market drivers: technology change, green transition, demographic shift, right? What is demographic shift? This is happening all over the world, especially I think in Japan. The older population is very high, and in even our countries, the older population is becoming higher, and the younger generation is shrinking, right? And we have more and more working age people, right? So this is, the demography is shifting very, very fast, right? So are we ready to address that? How are we going to address that? And so on. It's a concern. And of course, economic uncertainty and everything that has happened in the last few years. So when you're looking at this, okay, let me just skip to the other one. If you look at trends in AI and robotics, it's basically going to change the world. I mean, that's we already know, right? So AI, information processing, all that is going to take up all these jobs. So if you look at the prediction of the amount of jobs, the number of jobs that going to be either done by technology or a combination of technology, is going to move from somewhere to 50% to 65% within the next 5 years. This is the prediction. But the most important things, I had this slide for the last few years, every year changing with the job reports that are coming out. These numbers are changing widely. The World Economic Forums have no idea how things are changing, right? But what you're seeing is these numbers keep changing and growing every year. And even the World Economic Forum and the experts have no idea how things will change. Every year it actually keeps changing. So what we'll see in the next year job reports. It will be very interesting to see. But what we know for sure is that a lot of jobs going to be replaced by machines or a hybrid. So, right? So then the question comes, the humans and the machines, are we going to lose our jobs? Now, the interesting thing is, if you look at the aspect, the largest growing jobs and declining jobs, if you look at these things, so the important things, like, for things like largest growing jobs, the numbers, right? The farm workers, laborers, light truck or delivery service, and so on, it's actually number one, because it's very difficult to replace, and they actually more and more demand for farmers and all that. But there are things that most fast declining. What you're seeing is, cashiers, administrative assistants, accountants, all these bank tellers and all that, which are being automated very, very fast, right? Nobody's going to the bank anymore. You are using online banking, ATM and all that. Ticket sales, everything is all online. So you see the jobs that are declining. And fastest growing and declining jobs by 2030. This is the speed of change. This is the size, right? So the big data, fintech, AI, software, security. So all these AI technology related jobs are the fastest growing ones, as you can see. The other side is, again, they are all things which can be automated easily. Postal services, of course, nobody's using postal anyway. Bank tellers, data entry clerks, cashiers, ticket sales. So these are the things that are being replaced very, very fast, right? So what we see is that, what the World Economic Forum is saying also, 39% of the workforce core skills will change. Core skills. Now, what we're talking about, not the, Sri Lanka or the developing countries. This is actually looking at the entire world, developed world and all that. But even then, the 39% of the core skills that they need for a job will change, right? Meaning, meaning that a larger population has to change the core skills. Now, what are the skills? I asked this question in the survey, and you rightly identified these skills, right? What are the skills that the humans, we differentiate humans from machines? Now, you correctly identified these skills that you need as analytical thinking, critical, creative thinking, resilience, leadership, motivation. These are things that machines will never be able to, or at least in the near future, will not be able to do. And this is where the humans will bring value. The analytical thinking, creative thinking, and so on. So the question that been asked, like, will AI replace? Yeah, they will replace this repetitive, boring, easily replaceable task and things that we actually hate to do. Right? If we are really good, if you want to just do a repetitive jobs, then we are in danger. But if we want to really use what we are good at, what makes us humans, the analyticals, the creative side of it, the curiosity, the leadership, and all that, then that is not going to be easily replaceable. So this is basically right? Okay, yeah. And if you look at the reskilling need, except for about 60% of the workforce is going to need some sort of reskilling by 2030. That's what they say, right? Yeah. So this is this is something that we really need to look at. This is one of this purpose of this workshop as well, and we are going to do a lot more workshops or similar workshops here in Asia Pacific region as well as in Sri Lanka. The whole idea is that this reskilling in one area, but we need reskilling in many other areas as well. Right. I'll just skip those things. Yeah, the same numbers. And to the question about the job growth and job loss, yeah, we are going to lose a lot of jobs. The same as when we lost jobs when the industry revolution, when we lost jobs, when the printing press came, when we lost jobs with other things. Yeah, every technology will lose some jobs. But what we have also seen is actually it creates more jobs as well, right? Computers might have made the typewriters to typists to lose jobs, right? Right? Yeah, exactly. So so you need to reskill and you have to adapt, and there'll be more jobs now, right? The data entry operators are many more, but they are going to lose jobs. So basically, what they're saying is we'll lose about 92. Like these numbers, once again, as I said, last year numbers this is different from last year. Previous year again different. But what the same thing that every year it says is that you're going to create more jobs than you lose, right? So it's about reskilling. So it's basically what they say is like AI won't replace you, someone using AI will, right? So you need to do that, and then I mean there are enough things, enough tools. I mean even when I teach AI and if I teach machine learning, actually Damayanji teach machine learning mostly, but if I do, I mostly get deep learning AI. Or Coursera courses, and I get them to do this because these are taught by Andrew Ng, who's a Stanford professor, who's a complete authority in AI. Why should I go and pretend that I know better than him? Because if my students can learn from Professor Andrew Ng from Stanford, I mean they're learning from the best in the world, and you can too, right? There are enough courses. These are free courses you can go and do. There are many such courses in online. If you want to get the certification, you'll have to pay, but you can just go and learn all these things. So there's enough resources online that you can do and learn. Okay. Right. So AI and society, this Roshan will cover tomorrow. So I'm not going to touch that today. For the ethics and the reality, all that. Quick look at GenAI, and I'll give to Roshan, as I said right at the beginning. The first session, it's all about we talking, okay, until you get bored, so that you want to do something, right? And then from next session onwards, we'll get you to work, and we'll just sit back and relax. So quickly on to GenAI. I'm not going to go into details. So generative AI, of course, it's basically generating new things. Don't worry about the text. So it's generative AI is creating new different things, images, text, videos, and all that. Large language models is the generative AI in the text area. There are other things as well, but creating text. GPT, generative pre-trained transformer, is one type of large language model. And there are such other models as well, generative adversarial models creating images, transformer models again creating images, and so on. There are a lot of different models, but you don't have to worry about it. You just have to understand, just how to use it properly. So how to use it properly? Okay. Okay. This I mentioned earlier why this is there, so I'm going to skip that. Ethical use also Roshan will touch tomorrow. Today, anyway. Tomorrow, yes. Right, so we'll quickly jump to prompt engineering. I'm not going to do the prompt engineering one. Roshan will do it, how to do it properly, how to focus, what to focus. But just what's prompt engineering and what I'm doing it prompt engineering, right? So, of course, as you all know, what's prompt engineering is how to ask a question from GenAI and to get the results you want. It's not as simple as just asking. It's the same thing as maybe Google search. Everybody can do it, but how to do it properly and what, right? So and understanding what it gets like. You can ask simple question like, what do you call someone who keeps praising a leader even when they are wrong? The answer is sycophant. And why I use this example is there's something called sycophancy in GenAI. You know what sycophancy is? So sycophant is somebody who praises. So sycophancy is somebody basically praising you. Now if you have experience with GenAI, if you go and ask a question from GenAI or give something and say, what do you think about this one? What do they say? Oh, this is great. Oh, this is amazing. You have done something. You give your CV and ask, they will say, oh, wow, you are so good and all that, right? So you need to understand this first, right? GenAI is usually a sycophant. It will try to praise you. It will make you feel good about you and all that. So it's very important for you to get it to be critical and look at all sides. Otherwise, it will give you a false sense of hope, false sense of good about yourself, and you might fall into the trap of thinking that it is really good. So this is the first thing you need to understand. Just don't believe as it says, because it will not. Now it will not be like it will not be like your spouse, critical of everything, or it will be not like your best friend who will make fun of everything, right? They're supposed to be, right? How will you get better otherwise? Do you want some spouse who will say all good things about you? It's no improvement, right? You want your spouse to be critical. Yeah, sorry, Kajita. I'm not arguing with you. Very sorry. Sorry about that. I take it back. Oh, come on, take it. What, Kadisha? Okay, right. Sorry, I take it back. My bad. Okay, right. So I mean, you can do different things. Like, I mean, I don't even like even naming things. AP gained. I didn't come up with it. ChatGPT did, or Gemini, I can't remember, right? They come up with very brilliant, absolutely brilliant names, right? So use it for that one. So every problem, like AP gain proposal, I wrote in 3 nights, right? Earlier, a proposal like that would have taken me at least 6 months, meaning it will never happen. Right? I will analyze and reanalyze and all that, and starting to write will take about a couple of months, and then the deadline is gone. You just give it up and hope that you'll do it for the next time. This one, we've been thinking about that one and all that. It's not even 3 days. It's just 3 nights. From maybe 11 o'clock in the night until 3, 4 in the morning. 3 nights, done, and it was a very competitive grant. It's 184 applicants, and we were one of the 10 or 11 winners of that one. It's not that I just asked the question and I wrote the answer in that one. No, its idea is mine and Roshan's. Right? So we have been thinking about it, discussing about this one for a long time. And then we come up with all the ideas in our head. So we know what it's going to look like. And what ChatGPT and Gemini gave me is actually better than even we thought about it. But its idea is mine. And so this is actually a proposal for some other multidisciplinary research center that we set up in Peradeniya. I mean, you give the idea what our motivation is. So this prompt is about, I think, 3-4 pages long. And I give the format, how long the summary, the methodology or whatever, all these sections has to be, how long it has to be, what it should encompass and all that, and it will generate something, right? The prompt that I use, so at that time I had ChatGPT Pro, I could upload the file, so I would give it all the background, like, the Beijing Proclamation, UNESCO guides, all the things I uploaded, and told my vision as well, and say this is what I want, these are the sections I want, and all that. And I generated Gemini. I couldn't upload files at that time, so I created my prompt. My prompt was 37 pages long, right? It's prompt is it's not a question, it's like all the data. All the data was 36 pages long. I gave it, it generated. Did I copy paste it and submit? No. I refined every section as I want. And things are changing very rapidly, right? So this is, I'm talking about 1 year ago. At that time, if you look at GPT versus Bard, the Google engine, Bard is very creative. It writes very nicely flowing language, whereas GPT used to be like very formulaic, very precise documents. So in creating APGAN proposal, I like a motivation introduction, I use Gemini input. To create the methodology and output and all that, I use ChatGPT. So different parts. And what I actually did, that one is like, I do this, I ask ChatGPT, I ask Gemini, I create, I just copy paste into Google Docs, multiple things. So I have like 6 different drafts. I look at each one, get good parts from everything, put it back again into ChatGPT and say, this is what I want, but I want these changes also. So that's why it took 3 days. Otherwise, I would have just done it in 5 minutes, right? So I change everything, I get it, combine things, put it back, refine it, put things back, and by 2-3 days, I have like the perfect copy I want, and actually be even better than I imagine, right? So you can give the image, like, pictures and all that, files and all that to do this, right? And also like in different fields, like, it makes learning very easy. Like, I have like, even in my class, I don't answer any questions anymore. I use a platform called Perusal, where I put the notes, they ask questions and answer, like others can answer, I will also answer questions for the notes. Now I just go and, when they ask question, I would just go to ChatGPT, get the ChatGPT answer and copy paste there. And when I do couple of times, they also learn that one, and they don't even ask. They ask a question and they put the answer also. So now my work is done. I just put the notes, they ask questions, they answer questions from ChatGPT, my whole work is done. But the fascinating thing is, I have trained my son also to do this, because, this is biotechnology. So what is biotechnology? Give me long thing. I said, okay, this is very boring. Just give me a simple one. And then it's like giving me like, okay, this is this, right? So this, it gives, and then recently with DeepSeek, I actually went and asked this one, and this is the best ever definition of biotechnology that I have seen for a non-biology person, right? It's really great answer, and it shows everything. Because my wife is biotechnologist, and she's like molecular biology, biotechnology. She's been teaching this, and I have been working on a lot of biotechnology projects. I know these things, but not to this things to this level of precise explanation. That's really great explanation. And so this is like, and also like, DeepSeek, I've been trying to do these translations for a long time. ChatGPT, Gemini has not been that good, but DeepSeek is much better. But it keeps changing, right? Every day it keeps changing. But this is like, very precise thing. But the thing is, it's like, so one of the things that you see is, it keeps evolving day and day, right? Right. Let me just quickly go. Yeah. So you can use for learning and all that. There are different plugins like the Tutor Me and all that. You can for learning, lesson planning, and research. So this is with Gemini. Doing LLM using for patient letters and things, tools like Consensus, which used to do, and then we moved to Perplexity. I'm using Perplexity mostly now. I saw that a lot of others are also using Perplexity. I even use Perplexity to actually to kind of paper review as well now. Administrative process to see, this is what we will see in the afternoon. And also, yeah, personal assistant. I know how many of you using any personal GPTs and all that. So this is basically in ChatGPT. I'm using this personalized GPTs. This is called Leah, Learn Enhance Intelligent Assistant. So this is she's who's writing all my things related to learn. So AP gain proposal and all that. Now I have uploaded everything, all my about me and learn and what we are doing. So I don't have to even go and do my prompt like background anymore. I can go and just ask Leah, what's happening? Okay, what we do have now? Can you give me a brief? She knows everything about what is happening. I'll keep updating her regularly, so that anything to do with Learn and AP Gain, all these projects, I just go to and ask. I said, okay, I have this one. Just give me a quick letter, and like she'll know all the background. Just do it. Like so this. So I have created similar GPTs for for example, this is letter of recommendations. Like your students are applying for higher studies. I have uploaded all my previous recommendations I have written. So now it has learned my style. So now I give the CV of the student, their statement of purpose, and the university they are applying to, and whatever the requirement they have, write a letter. I just have to look whether it's all okay. That's all. Earlier, writing recommendation letters takes like very, very long time. Now you are just done like that, and it writes in my style too, because it has learned from all the previous recommendations I have uploaded. Similarly, I should not show this to our vice chairman. This is like degree evaluations, program reviews. For we are doing program reviews of other universities, and I have created another agent to do that. My previous reviews and all that, SLF, QF, all that, put it there, put the new program. I'm not just going to copy paste this one and send the program review, but this. Sorry? Yeah. Right? So I will get it to do the analysis things, compare whether it is accurate, and then put it in the report. Earlier, this kind of report will take days because you have to go through everything one by one. Now it just evaluates. I can just write it in 1 hour, maybe maximum 2 hours, maximum. Right? So there are a lot of things, and they have started thinking also, right? You see them thinking and thinking and thinking a lot, like very deep thinking. So that is perplexity thinking. And this is like deep seek. It's thinking like, for like 59 seconds it's thinking. It's just the thinking process is actually more interesting than the answer. Because like this is what I show this is actually my son's thing. I ask a question that my son is teaching. And then a comparison between this couple of literature things. And it's going through this one, how it thinks is actually much better than the answer. Because like you can see this is like, oh, he must be asking about this one. No. I have to think about this part also. Maybe let's see. Maybe this is what he wants. Like this, just going back and forth between like different parts, which shows you the analytical side of this thinking, which is actually much better than just giving the answer. This is so and deep research. So this is. So I'm trying to apply for my professorship. Don't get time because I have too much work. So, but there was this one part where this is 2 sections about, one is curriculum planning, other one is course, introducing new courses. I said, what's the difference, right? And then I asked the question. He asked me, he gave me a very simple answer. Say, tell me the context. I said, no, I'm thinking about this professor application, and there's this question. What is the difference? And then it started doing that analysis, right? So it went through 25 sources. It didn't even ask me where I'm from, anything. It went through UGC site, everything. It went through so many sites, and it gave me like a very long answer, giving all the things and all that. And every question I ask about afterwards. So I was looking at different courses and putting that. It will tell me, okay, you can put this part into this section, you can put this part into section, this is how you write it. I mean, there's nothing really to do at the moment, right? So this is like the power of things. This is just, they are from the last few weeks, like the deep research in ChatGPT. So what will happen in the next 6 months, year, we don't know. So let's see how it goes. So I've taken, I think, longer than I should, right? So I'm going to hand over to Roshan to mastering prompt engineering. We might run into a little bit into the next session as well, but we'll start working on it and start the hands-on in the next session, as I said. So all the talking and the boring parts will be over even very soon, and we'll get to the exciting part in the afternoon session. But before that, let me invite Roshan to take over and do the prompt engineering masterclass.
Very good morning. Good morning. Thank you. Right. So let's, sorry. Why is that? Too much talking. Asita is doing too much talking. Right. 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 So let's start the discussion about prompt engineering. Just to start with, in fact, Asita has given justice to explain why a technology like AI is changing the way how we work, how we live. And I'll start with this slide quickly to compare the performance of different AI systems. Not AI system as a whole, but individual different systems. Just to see if you can compare. So we are comparing against human performance, 100% human performance. So if you just take one or two examples, like for example, the understanding of languages, how AI systems can understand languages, or particular AI system that is built to understand languages compared to people. In fact, compared to average human, these systems can now do better. In fact, things are getting exciting and sometimes challenging, where even computer systems or AI systems can do things like common sense or completing common sense. You know, like when you talk, we use common sense and our understanding of the world to complete sentences, for example. So there are tests. So that such tests, by 2023, AI tools can do as good as human. This graph is coming from a little outdated now, from 2023, and they can actually do better now. Not just that, when writing programs. Software engineers or engineers, we build them for a long time so that they can go and write efficient programs. Now AI systems can do. So with this, all these challenges, on the other hand, things like generative AI, the Gen AI tools, come and change the way how we work. Here is again a comparison starting from the time of deep learning, and they changing businesses. Business could include NREN, research, education, all that. All these different businesses. The graph here shows if you take 100 businesses, how many of them will or is or are using AI in their business functions. The numbers used to be about 50% in the last several years. About 50% of the companies were using AI at least for one of its business function. But the numbers are increasing again with GenAI. GenAI, now the numbers, these are again up to the first quarter of 2024. I'm sure when the report comes back again, the numbers are going to be 100%. Every company, every business is going to use at least one of its business function with AI. With this, the way how we use AI or how we can utilize AI, and particularly with machine learning, particularly with now natural language processing and generative AI, things are changing a lot. So with generative AI, and we can use natural language to talk to these machines or talk to these systems. We can't or we don't now need specialists. We don't need programmers to come and write programs. We don't need anybody else, whatever field we are in, bioinformatics or biologist, agriculturist, all of us can go and use these systems. And the good part about it is that we can use the systems in natural language, in our own language. We can talk to them, or we can text, voice, all this we can do. But the challenge is, can we talk to them the same way how we talk to people? Can we talk to them the same way how we talk to people? Right? It is natural language. They are going to respond to natural language text and voice, but are they going to respond how people would respond to the same questions I ask or the same prompt I make? The answer is it depends, and also it depends on the AI system's understanding of the world, the AI system's understanding of the context, the AI system's understanding of the society. I won't go and talk to people outside this room the same way how I am talking here. If you come and meet me outside, I won't talk exactly like this. I'll talk a bit different. I have a different tone, right? I'm in front of 50 people, I talk differently. Now, can I make AI to do the same? If I want to interact with AI and if I want it to do the same thing, expect to be expert, expect to do all these things better than people, can it do it? So that's where the idea of prompt engineering, some common sense to understand these machines don't have all the context we have, right? So the machines don't understand that you all are now sleepy. Right? That's what you said. They don't understand. So can we understand what the machines can understand and use it to our advantage so that we can do better? The idea of prompt engineering is that. The idea of prompt engineering is understanding what these AI systems do, how they understand world, how they respond, so that we can do a better job, get the best output possible. That's what we are trying to discuss. So with the remaining half an hour plus, I'll quickly go through these topics. I'll actually start from two. One, we have done enough of introduction on GenAI. And starting from some strategies for better results. So how we can use a certain type of strategies when you are writing prompts so that we can get good results. And then there are a number of advanced prompting techniques. There are some frameworks, we call them. So things people have figured out over time by knowing how these systems work and by understanding how they respond. So by knowing those, they have come up with certain number of advanced prompting techniques. We'll talk about them. And I'll finish with some optimizing and safeguarding ideas, how we can keep them ethical. We'll talk more about ethics tomorrow, but we'll just touch upon them. In fact, Asita spent enough time on this, introducing what AI and GenAI is, and therefore I'll skip. Prompt, as you know, we can use prompts with GenAI to generate text, images, video, and whatnot. Anything that you can think of, multimedia, text. But when you want to ask a generative AI tool without any context, so here I'm asking, this is ChatGPT sometimes back, generate an image of a Python programmer. So those who are in programming would know what Python is a programming language, and that is the question I asked without giving any context, no context. Imagine what the output could be. Okay, a snake. That is programming, right? So the good part about it is still the AI seems to know that there is something Python, which is a snake, and also at the same time it's about programming. In fact, this is sort of confused, as you can see. This one is actually a logo of the Python program, those who know about programming. And obviously that's a snake, and then there are some programs, right? So we can easily confuse a system like this without giving proper context. That's the idea, right? So can we, by the way, if you go and do the same search now, you won't get the same answer. Things have improved, right? Now you'd get a real Python programmer person who is programming, right? So, but the point is, we'll have to give the right context to get the right output. Prompt engineering has become, with generative AI and natural language processing becoming mainstream since the last few years. Prompt engineering has become one of the most popular courses in several even open course platforms, MOOCs and so on. So here are some examples. So now that we are going to do it in half an hour, you can go and do like a full course, like a 3 months or a 2 months course on prompt engineering if you want to go deeper. So here are some examples, such courses, one from Google, IBM, and also universities from Coursera. But what all these courses are trying to identify is how we can write better prompts. So to do that, understand what these prompts are supposed to have. So I'm going to touch upon a few of these aspects. I'll just highlight a few aspects of what is expected from prompts so that we can write better prompts. The ultimate objective, obviously, is to get the right or good output or better output. Output that is, as we claim, better than how we would get from a human, right? So in these situations, that's the whole idea. And obviously, even when you are using prompt engineering, like it was already highlighted, we always had to be part of the process. Even if you are getting a response from a prompt, it's our responsibility to be part of the process, making sure the output is checked by human. Why do we need prompting? Or why do we need these techniques? Obviously, to get quality response. Not just that, we can also save time by knowing how we write better prompts, and therefore we don't have to spend a lot of trial and error, and we can do things faster. And there are concerns on AI systems. They are not very much deterministic. They are not very consistent. You ask the same question 2 times from a generative AI tool, and you get 2 responses. And you are concerned about it because you can't reproduce, right? So we, mostly being in the education and research field, we want our results to be reproduced so that we can depends on them. Every time we get the same result. So by crafting the right prompts with the right set of input, it's possible for us to be consistent. So that's something that we had to worry about. Obviously, AI systems are very expensive. They consume not just money, they consume a lot of power and contribute to the carbon footprint. They consume a lot of cooling, so contribute to water shortage and so on. So these problems can also be overcome if we use the right optimization, so the right prompts, so that the minimum amount of text I remember, or hope you remember, Asita was talking about a prompt with 37 pages. I think it's 37 if I remember right. So it's a lot of text. And when you send this text to a generative AI tool, it's going to process through this 37,000 or 37 pages of text. And processing this text is a bit expensive. In fact, we'll talk about it during the ethics of it. Something like 100 word text to generate OpenAI with their ChatGPT or the GPT-4 model, they have predicted or they have calculated to generate 100 word text, it takes about 140 watts hour, right? So that's a lot of power. In fact, like we can use that power if you are generating 100 word text. The same power can be used to light like some 15 LED bulbs for 1 hour, right? So that's the amount of power we are spending if you use, so maybe that's about 15 LED bulbs here in this room. So 1 hour power by just one prompt to get 100 words done, right? So it's a lot of power. So we had to see how efficiently and optimally use AI instead of lavishly use it and contribute to not achieving our sustainable development goals, which we are keep on moving further and further trying to achieve. Right, so with that, let me just go into quickly some strategies to get best results. One, which is very obvious, in any communication, we had to have clear instructions. So writing clear instruction is something very simple to say, but just take some examples to explain, right? I already gave an example about the Python program, just to again illustrate. If we want a prompt to give the right output and also to give a consistent output, make it more detailed. Make it with the right context. I'll just take one example out of the 3 here and read it out. Here is one. How do I create a project plan is a possible prompt. And a better prompt would be, how do I create a detailed project plan? We don't just stop there, but we give more context. We say the project plan is not for a project that is running, but for a new project we want to start. Not good enough. We'll also go into say more details about this project or what we are expecting. So you're asking to include steps for market research, budgeting, product development, and marketing with timelines for each. So we are giving more details. So instead of just keeping the prompt open and letting the AI systems or GenAI models to figure out what to give as output, we can specifically say this is what we want as output. And this is the situation in a more detailed way. So such prompts are better. So we sometimes being lazy, we can produce prompts that are very short, short-sighted also, and therefore will not get the output that we want. So but by doing this, we can get better outputs. So there are the examples. I'll not go into all of them one by one. One other challenge we normally see is, again I'll take the example from Asita, 37 pages of prompt. Out of the 37 pages, only a couple of pages or even less would be the real instructions. The rest are data, right? So when you give data and instructions together in a prompt, it's good idea to separate them clearly. Separate them out clearly. So this is data, this is prompt. The reason is, if you give a lot of data, if the data has some instructions or some questions, data might have, because data is a lot of text. It can have question and answers, FAQs. It can have all sort of different things in data. So such data, when you put them in a prompt, what happens is the prompt or the LLM or the generative AI models can get confused. And might take the data as also as the instruction or the command or the request we are asking. So one possible option is to separate. So here is just an example. So here I'm saying summarize the text below as a bullet point list of the most important points. And I'm giving text. Instead of just giving text, text could be just another paragraph. Instead of doing that, I can separate this and I can clearly identify text. I can put them in quotes, so it's very clear. Right? So this way, it's very clear what is the instruction and what are just the text. More, I told you about the way how we speak depends on the situation, the tone we want for the output. So it's possible when we want a specific output, we ask it in the prompt. So we can specifically say the format of the output. We can also specifically say the length of the output. So here are the formats. We can say, okay, I want bullet points, I want tables, and anything else. I want specific formats, I can say. Not just that, I also can say what's the length of the output, or how many bullet points I want, or how many steps I want. By giving these details, I can get better output and desired output particularly. So here is an example, right? So instead of instead of just asking it to summarize the text, we can say, we can specifically say, okay, here it's about a movie. So I'm asking extract key information about a movie from the given text, and the text is given at the bottom with quotes, so it's very clear. And then I'm also saying desired format, and specifically saying give the output in this format. The format could be just a table. Ask it, you can say a table with columns. Now all that I can specifically say. So giving specific details about the output format gives me better results. One other aspect that we have seen through a lot of experiments is that when you have long prompts, this idea of double down works better. The idea of double down is this. So instead of using instruction content in a prompt, the examples we took earlier, we had some instruction, do this, here is the text. So text is the content, do this is the instruction. This works better. Instruction, content, instruction again. So you don't put all the instruction on one side and you put all the content on the other side. You put instruction first and then content and then instruction again. Normally what I do is first part of the instruction, I say some context, and then you give some content, and then you say the next part of the instruction, you ask it to do something, right? I'll show examples, but this idea of double down works pretty well, breaking the instructions into two parts. First you start with a part, then you give some content, obviously the content in quotes, and then you finish with more instructions. We were talking about the problems in AI systems. One of the problems is it can't say I don't know. Usually it doesn't say I don't know. If it doesn't know, we had enough examples and situations in the beginning of this generative AI ChatGPT beginning. There are a lot of situations where it came and hallucinated. In the academic circle and the research circle, we have a lot of examples. It generated a lot of papers. It just made up papers actually, right? It just came up and said, okay, here is a paper on this topic. These are the authors. These are the titles. When you go and search, no, they are not out there. Just generated, imagined, right? So situations like that are examples of hallucination, and we'll talk about them more later. But how do we overcome such situations, right? One is to give a way out for these models. Way out meaning when it doesn't know, like for example, I'm asking a question here, provide a proof of a certain hypothesis. Rayman actually. So if it knows the hypothesis, it's going to give an answer. If it doesn't know, it's going to hallucinate. So how do I avoid it? Is by adding more things to the prompt. The adding more things part, I am calling it giving a way out, right? So we ask the same question, but we also add more. If you don't know a proof, respond by saying I don't know. So include in the prompt a part for the systems to say I don't know or say no, right? I don't know, no, these are things we don't normally say, right? So this AI systems also they don't, right? So therefore, it's a good idea to tell this, give it as an instruction, part of the instruction or part of the prompt, so that we get better results. So we get responses where if the system is not clear, it gives, I don't know. More strategies. So all that what we discussed earlier are more on the writing clear instructions. More strategies is to provide reference text. In fact, reference text I already mentioned earlier as well. But whenever possible, again I'll take this 37 page as an example. Whenever possible, give references. Give references within your context. You know, particularly places like studies, students in a learning environment, we want learners to learn things from a particular context with certain references. So the learning tools are built in that sense. For example, the most popular Google's Notebook LM is using that idea. Or there are other platforms like Unstuck. So these platforms, what they do, we can upload textbooks and then ask and work within the textbook. So given references in prompts, either through a tool like Notebook LM or even ChatGPT like generic chatbot platforms, giving references is a good idea. So we give as enough references as possible, only as enough, not more, right? So not more, we are going to overburden the system and consume more power and like water. So give references. I'll not go into the examples here because we already discussed it earlier as well, but the idea is as much as possible give references. And also it's possible to ask the systems to give answers from the references with citations. So we can ask, okay, tell me the answer where in my reference it is. Here is a book, here the question, give me an answer with the reference, with which page the answer is. So such things will give better results and also verifiable results. In fact, when Asita was talking about doing a review of a degree program, there are like thousands of pages of documents. So if you're asking a question and if it's giving an answer, it's better, it also tells us which page it found the answer from, so that we can go and double check and also provide it as an evidence. So those are useful. So make sure we ask, whenever we are providing references, ask for citing. So it can cite the AI tool, whatever the tool you use, cite from where it found the answer. So that's one other tactic we can use. One more is giving these models time to think. Again, the new models where there is deep research parts are involved, the model is made to think more. So we are also seeing enough examples, starting from actually the chatbot that was built by Khan Academy called Khanmigo. So Khan Academy, as you are might be familiar, is a US-based company, but they are building MOOC or openware learning material, and they built a chatbot, and they started teaching. They are teaching maths for a very long time. When they build a chatbot using ChatGPT OpenAI API, they realized it's not doing well. It's doing really bad with maths, right? So this was in 2023 early. And then what they did was, they have made those OpenAI API to think an answer or to elaborate answers step by step. When you do such things, we see the answers particularly in places where there's multiple steps and maths involved. When you do steps, the system does better, and the models give better answer, because the broken down smaller parts are easier to verify, easier to produce answers with compared to a full length. Because remember, all these large language models are trained on language, not on logic, not on maths. So that gives better answer, right? So without rushing to a conclusion, we can ask these models to give step-by-step answers. One other alternative is we give our answer. So here is a situation where I am giving my answer. The question, I'm asking the question, and then I'm giving my answer, and I can ask it like this, give my answer, give a question, and you can see my answer is actually, this is a situation where I'm talking about marking a student assignment. But what I'm saying is, don't decide if the student solution is correct until you have done your own, right? So we can make it to think, give its answer, another answer, compare to. It's also possible for it to give, ask it to give two answers and compare both the answers and give a better critical analysis of the answer. So it's possible for it to, for us to ask the system to give you multiple answers and then compare the answers and give us the best answer possible, or to critically analyze an answer. These things are all possible. So these are making the model to think, take time to think and get better. So those are some strategies. Let me move on to some advanced prompting techniques. In the interest of time, I'll not go into all the patterns detail, but I'll take examples. I'll start with persona pattern. The idea of persona pattern is we tell the AI system to behave like somebody, right? So here is an example. From now on, act as a professor of educational psychology. Pay close attention to how cognitive development impacts learning strategies. Provide outputs that a professor would regarding this input. So this is a pattern known as the persona pattern. The idea is you make the system to narrow down its scope into a specific area and then focus on it to give answers. And also we are expecting it to give an answer at a higher level as a professor, where a professor would consider a lot of facts before giving answers, or analyze things before giving answers. So that's one example, a particular pattern. There are more patterns like this. So I'll share the slide so you can look at the descriptions. I'll again take an example for the second one. Is known as the flipped interaction pattern. The idea of flipped interaction pattern is we reverse. Normally, we would ask AI questions and we will get answers from it. We can make it swapped. For example, when you are learning, if you are a learner, you can do the opposite. You can make, so you can see here, we are asking AI to ask us the questions before it decide and give the right answer, final answer. Right? Say from now on, I would like you to ask me questions to better understand my challenges with time management in college. When you have enough information to provide guidelines, create a personalized study plan for you. So that's reversing, or it's called the flip interaction pattern. Next one is on refinement, question refinement. So in addition to asking a question, we can ask it to refine the question better. So from now on, when I ask a question, suggest a better version of the question. To use that, incorporate information specific to a topic or a use case. So we can ask it to help refine questions. Verification is one more. So here you can see we can ask, so we got a response from AI and we can give that answer and ask more. Now, so that we are giving the answer back to the AI. This is what you gave as an answer. But now, challenge this response by highlighting any possible errors, biases, or alternative explanation. So we can ask it to challenge a certain response it gave, and by doing it, we are making it to verify. So these things we do even with learners and others. So we can do the same with AI systems. Reflection is one more. So here, the next pattern is on reflection. So we are expecting, so when you provide an answer, here's another prompt. Please explain the reasoning and assumptions behind your response. If possible, use specific examples and provide evidences to support your answer. Please address any potential ambiguities or limitations in your answer. So by doing that, we are asking the system to reflect on, meaning think and go through steps before coming to an answer. I know I'm going very fast, but these are some repeated ideas. And one more is there's this concept of zero and few shot prompting. The idea of the difference between zero shot and few shot prompting is shot meaning we give examples. Right? I'll just take one example to explain. I know you also have to bear with me because you also have to go for lunch on time. So the prompt is here. Here's an example for a few shot prompt. First I'll take the one shot prompt or a zero shot prompt. I can ask a question like this. Explain the concept of anything. I'm just putting a topic like feedback loop in control systems. Don't worry what it is, but I can ask a question like this. Explain the concept of a certain thing. Instead of that, this is called zero shot, meaning I just ask for a concept to be explained without giving any examples. But I can do the same by giving few shots here. Explain engineering concepts in simple terms. Here are a few examples. I am giving examples. Gears. This is what a gear is. I am giving enough information in an example so that the output will also be very similar. What is an engineering? In engineering, what is a circuit? I give examples. So that's called few shots, giving examples. And then I'm asking now explain the concept of a feedback loop in simple terms. So the first part and the last part are still the same, but I'm also giving examples so that output that I'm going to get will be of similar nature. Examples, again Asita brought up writing recommendations for your whoever, right? So co-worker, student and so on. So situations like that, we can give example. This is what I have produced for this student. This is what I have produced for this student. Here is a new student, produce one for me, right? Giving examples. They are called few shot prompting. More on prompting, chain of thoughts is another idea that's very useful. The idea is we don't do, let me again take an example to explain. So we can give an existing prompt and ask it to explain your reasoning. In fact, if you are using some specific models, like even now DeepSeek has a research model, ChatGPT have the Plus and the Pro versions has what is known as again, what is it called? Asita, is it called research? Deep research? The research model, deep research. The deep research option. So if you are using the ChatGPT Plus version, you have deep research option once a month for about 10 times. And DeepSeek has it by default, but it's a bit slow and not available most of the time because of. So those ones automatically does it. What they do, they look at a prompt and go into deep research, analyzing different parts of what is going on and give an answer. But even if you are in a normal setup with the prompt, you can do at least part of it. So what you can do is you can give a normal prompt, the prompt that we discussed. On top of it, we can ask, explain your reasoning step by step before arriving at a final answer. So by giving this, you can get better prompts. So by combining chain of thought and few shot prompting, we can arrive better example or better answers. This is coming from a research paper, pretty old as you can see in the generative AI era at the beginning. So when you do prompting like this, which is straightforward, a mathematical problem, the answer you got was actually wrong. But when you ask it to do chain of thought and few shots, so chain of thought is asking it to think and go step by step and do. And the other one is examples. So here them examples are given. When you do examples, it gives answers step by step. It gives the thinking pattern. And when you do it, we realize we are getting the right answer. This is in a simple maths problem. I mean, not very simple, but straightforward. Yeah. So chain of thoughts, where we make it to think, and few shots, where we are giving examples, give better response. Right. So that's more. And let me quickly wind up with the last topic. So how we can safeguard and optimize prompting. In fact, I'll spend some time tomorrow morning talking about the ethical aspect of AI tools, how they can be useful, how generative AI can be used ethically and responsibly. But just to highlight a few aspects, make sure any one of these prompts we use, we have to make sure they are addressing biases. We'll discuss more on bias later, but I assume you know a little on it. The biasness depends on our experience. Here, the tool's experience, so the like the large language model or the GenAI model's experience. Their experience is basically their data. So it depends on the data, the responses we are going to get are going to be biased. So it's possible for us to take a few steps, writing the right prompts and looking at the prompts, looking at the responses, iterating the process, redoing this multiple times, testing and reiteration can give us better results. I'll discuss more on it. Better results by reducing hallucination. Hallucination, I already mentioned what you can do, giving a way out, chain of thoughts. These are situations through which we can reduce. And confirmation bias is another problem. We all want to look for answers to something that we believe is correct, which is called confirmation bias, and there are ways of avoiding it by following what I discussed earlier. One more aspect is the latency, how long it takes to get the right answer finally, right? So by coming up with the right prompts, minimum amount of prompts, not to overdo, but to give the right amount of prompts out of the text, we get better results, and also we are going to save or reduce our impact or the AI system's impact on the planet. So reduction of that is better. So let me finish with that. So there are a number of elements on good prompts. So tips: give clear instructions, provide context, iterate and give an experiment, try things out. When you want to have, by the way, remember this, these prompts are generally, we are talking about repetitive process. We are going to use computers for repetitive process. Same goes with AI. So we are talking about optimizing your workflow, meaning workflow, things that you do every day. So we are going to talking about optimizing them. Therefore, it's about spending more time optimizing the prompts we prepare so that the workflow is efficiently done and they are done with less impact to the planet, right? So iteration and experiments and repetition is part of the process, and we have to make sure we are using the right tools and technology for doing these prompts. There are different tools for doing different activities even within GenAI. So here are some examples that we can use, but we'll look at them as we go. This is what we are going to do for the next 1.5 days. So I'll skip those. And here are some generative AI tools, including tools for making better prompts. In fact, there are tools like Prompt Hero, Prompt Perfect, Prompt Base. They can help you. They are generative AI tools helping you to make better prompts. And obviously, there are others like the regular chatbots, which are very familiar to you all. And there are different research tools or AI tools for doing research. Elicit, SciSpace, Consensus, Elicit and all are very popular. And Perplexity is another one that is popular, becoming like a alternative search engine for research. And usual writing and others. Image generation, integration with other tools like office tools and so on. So there are many. With that, let me finish, and thank you very much for being here and taking this step to improve your work, to improve your workflow. And also, I see that a lot of you are interested in becoming trainers and becoming the change agents. You can go and make this change in other places. We are happy to work with you all and making this a reality for our region. Thank you very much. We are breaking for lunch. Okay, so we are breaking for lunch. Thank you very much.